Venus is surprisingly compelling. Venus unveiled, a planet of extremes. This enigmatic world, shrouded in mystery and cloaked in a thick atmosphere, has long fascinated scientists and astronomers alike. Its beauty is deceptive, hiding a realm of unimaginable conditions. Before we delve into the possibilities, let's take a closer look at the challenge. Venus presents a myriad of obstacles that make it one of the most inhospitable places in our solar system. Understanding these challenges is crucial for any future endeavors. Venus, our closest planetary neighbor, is a planet of stark contrasts and unforgiving extremes. Despite its proximity to Earth, the conditions on Venus are vastly different. The planet's rotation is slow and retrograde, meaning it spins in the opposite direction to most planets, including Earth. Its surface temperature, a blistering 900 degrees Fahrenheit, 475 degrees Celsius, is hot enough to melt lead. This extreme heat is a result of the planet's thick atmosphere, which creates a runaway greenhouse effect, trapping heat and causing surface temperatures to soar. The culprit? A dense atmosphere, primarily composed of carbon dioxide, which traps heat with a runaway greenhouse effect. This thick blanket of gas ensures that the heat from the sun is not only trapped but also amplified, creating an environment that is both hostile and unyielding. If the heat weren't enough, imagine a sky choked with thick yellowish clouds of sulfuric acid. These clouds are so dense that they reflect most of the sunlight, giving Venus its bright appearance when viewed from Earth. However, beneath this bright facade lies a world of darkness and danger. These clouds, far from bringing life-giving rain, shower the planet with sulfuric acid rain. This corrosive precipitation is a testament to the planet's extreme conditions, where even the weather is a force to be reckoned with. It's a harsh and unforgiving environment. The surface of Venus is a barren, rocky wasteland, devoid of any signs of life. The intense pressure, equivalent to being a kilometer underwater on Earth, crushes anything that attempts to land on its surface. However, amidst this desolation, there are glimmers of hope. Scientists and researchers are constantly exploring the possibilities of transforming Venus into a more habitable world. The concept of terraforming, though ambitious, offers a tantalizing glimpse into what the future might hold. Venus, in its size and structure, bears a striking resemblance to Earth. This similarity, coupled with its proximity to our planet, makes it a tantalizing target for terraforming. The idea is to alter the planet's atmosphere and surface conditions to make it more Earth-like, potentially opening up new frontiers for human exploration and habitation. This similarity, coupled with its proximity to our planet, makes it a tantalizing target for terraforming. The challenges are immense, but so are the potential rewards. Imagine a future where Venus, once a planet of extremes, becomes a new home for humanity. The journey to that future begins with understanding the present, and the present is a world of extremes waiting to be explored and transformed. Earth's twin, why Venus? This question has intrigued scientists and space enthusiasts for decades. Despite its current state, Venus holds a unique appeal for scientists and visionaries. Its thick, toxic atmosphere and scorching surface temperatures might seem uninviting, but beneath these harsh conditions lies a world that could offer invaluable insights and opportunities. One of the most compelling reasons to study Venus is its size, which is nearly identical to Earth's. This similarity means that Venus has a comparable gravitational pull, which is a crucial factor for human health and well-being in the long term. Gravity plays a significant role in maintaining our bone density and muscle mass. On Venus, the gravity is about 90% of Earth's, which means that humans could potentially live there without the severe health issues that arise in low-gravity environments. Imagine living on a planet where your bones wouldn't weaken and your muscles wouldn't atrophy. This is a stark contrast to the conditions on smaller celestial bodies like Mars, where the lower gravity poses significant challenges to human physiology. Mars, with its gravity at only about 38% of Earth's, presents numerous challenges for long-term human habitation. The lower gravity on Mars can lead to muscle atrophy and bone loss, making it a less ideal candidate for human colonization compared to Venus. Moreover, Venus is closer to Earth than Mars, making travel and communication more manageable. The average distance between Earth and Venus is about 41 million kilometers, whereas Mars is about 78 million kilometers away. This proximity translates to shorter journeys, potentially reducing the risks and costs associated with interplanetary travel. Shorter travel times mean less exposure to cosmic radiation and other space hazards, making missions to Venus safer and more feasible. Historically, Venus has been a target for numerous missions, from early flybys to more recent orbiters. These missions have provided a wealth of data, but there is still so much more to learn. Future missions to Venus could focus on its atmosphere, which is rich in carbon dioxide and sulfuric acid clouds. Understanding these elements could help us learn more about greenhouse gases and climate change, both on Venus and Earth. By studying Venus's runaway greenhouse effect, scientists hope to gain insights into the potential future of Earth's climate. This knowledge could be crucial in developing strategies to combat climate change. Some visionaries even propose the idea of floating cities in Venus's upper atmosphere where conditions are more Earth-like. These habitats could serve as research stations or even future homes for humanity. Engineers and scientists are already working on designs for these habitats, exploring how we could live and work in such an environment. The potential for scientific discovery and human expansion is immense. In conclusion, Venus offers a unique combination of challenges and opportunities. Its similarities to Earth make it an intriguing candidate for future exploration and possibly even colonization. As we continue to push the boundaries of space exploration, Venus stands out as a beacon of potential, inviting us to uncover its secrets and perhaps, one day, call it home. Terraforming 101, transforming hell into home. Imagine a world where the scorching heat and toxic atmosphere of Venus are replaced with lush greenery, flowing water bodies, and thriving futuristic colonies. This is the vision that drives the ambitious endeavor of terraforming. Terraforming, at its core, is the ambitious endeavor of transforming a hostile planetary environment into one suitable for life as we know it. This process involves a series of complex and challenging steps, each requiring innovative solutions and cutting-edge technology. The idea is to take a planet that is currently inhospitable and make it a place where humans, plants, and animals can live and thrive. In the case of Venus, this monumental task involves two primary objectives. The first objective is to cool the planet down significantly. Venus is currently a scorching inferno, with surface temperatures hot enough to melt lead. The second objective is to transform its thick, toxic atmosphere into a breathable one. Venus's atmosphere is composed mainly of carbon dioxide with clouds of sulfuric acid, making it extremely hostile to life as we know it. First, we need to cool the planet down significantly. This could involve a variety of methods, such as deploying giant sunshades to block some of the sunlight from reaching the planet's surface, or using advanced cooling technologies to reduce the temperature. These methods are still in the theoretical stage, but they offer a glimpse into the innovative solutions that scientists are exploring. Second, we need to transform its thick, toxic atmosphere into a breathable one. This could involve introducing chemicals or microorganisms that can convert carbon dioxide into oxygen, or using advanced technologies to filter and clean the atmosphere. The goal is to create an environment where humans can breathe without the need for spacesuits or other protective gear. It's a daunting challenge, but not an insurmountable one. With the right combination of technology, innovation, and determination, we can overcome these obstacles and transform Venus into a habitable world. Scientists around the world are working tirelessly on this project, developing new technologies and exploring new ideas to make this vision a reality. Scientists have proposed several ingenious, albeit theoretical, methods to achieve these goals. These methods range from deploying giant mirrors in space to reflect sunlight away from the planet, to using advanced nanotechnology to manipulate the planet's atmosphere at a molecular level. Each of these methods presents its own set of challenges, but they also offer exciting possibilities for the future of terraforming. One such method involves harnessing the power of microscopic allies, photosynthetic microorganisms. These tiny organisms have the ability to convert carbon dioxide into oxygen through the process of photosynthesis. By introducing these microorganisms into Venus's atmosphere, we could potentially create a breathable environment over time. By introducing these tiny organisms into Venus's atmosphere, we could potentially convert carbon dioxide into oxygen, paving the way for a breathable atmosphere. This process would take time, but it offers a promising solution to one of the biggest challenges of terraforming. With continued research and development, we may one day see a transformed Venus, a world that was once a hellish inferno, now a thriving home for humanity. Steady decrease in surface temperatures, combined with other technologies designed to remove carbon dioxide from the atmosphere, These orbital mirrors could play a crucial locked away as vapor. The challenge lies in capturing this atmospheric water and delivering it to the surface of Venus, using their water content to replenish the planet's dry surface. While logistically challenging, these efforts would be crucial in creating a habitable environment on Venus. Section 7. Shielding a planet, the importance of a magnetic field. Earth's magnetic field acts as a shield, protecting us from harmful solar wind and cosmic radiation. Venus, unfortunately, lacks a global magnetic field, leaving its atmosphere vulnerable to being stripped away by the sun's relentless energy. To ensure the long-term habitability of Venus, we must find ways to generate a protective magnetic field. This might involve constructing a giant artificial magnetic shield in space positioned between Venus and the Sun. Another, more ambitious proposal involves reactivating Venus's core, potentially by inducing rapid rotation to generate a natural magnetic field. These solutions, while technologically demanding, are crucial for creating a safe and sustainable environment on Venus. Section 8. A united planet, global collaboration for a cosmic dream. Terraforming Venus is a project of unprecedented scale and complexity. It's a challenge that will require the combined ingenuity, resources, and collaboration of the entire human race. Nations will need to pool their scientific expertise, share technological advancements, and work together towards this common goal. This global endeavor will not only push the boundaries of human knowledge and innovation but also foster a new era of international cooperation. The challenges we face on Earth, from climate change to resource scarcity, pale in comparison to the task of terraforming a planet. By working together on this audacious project, we can demonstrate the power of human unity and pave the way for a brighter future for all humankind. Section 9, 2075. A New Dawn for Humanity Among the Stars. This is not just a chapter in a book, but a vision of our future, a future where humanity has transcended its earthly bounds and reached for the stars. The year 2075 might seem like a distant target, but it's a goal worth striving for. It's a milestone that represents our collective ambition, our drive to explore, innovate, and thrive in environments once thought impossible. Imagine a future where humanity has not only reached for the stars but has also transformed a once inhabitable planet into a thriving second home. This vision is not just a dream, it's a testament to our ingenuity and resilience. Picture cities beneath a Venusian sky, bustling with life, innovation, and the spirit of exploration. These cities are not mere constructs of science fiction but are grounded in the scientific advancements we are making today. Terraforming Venus is not just about creating a new planet for ourselves. It's about harnessing the power of technology to reshape worlds, to turn barren landscapes into fertile grounds for human civilization. It's about pushing the boundaries of human potential, about demonstrating our ability to overcome seemingly insurmountable challenges. Each step we take on this journey is a step towards a brighter, more sustainable future. It's about securing a future for our species beyond the confines of Earth. As we look back at our home planet from the vastness of space, we are reminded of the fragility of our existence and the importance of finding new frontiers. It's a testament to the indomitable human spirit, a beacon of hope for generations to come. Our achievements in space exploration serve as a reminder that when we work together, there are no limits to what we can accomplish. The journey will be long and arduous, filled with challenges and uncertainties, but the destination, a new dawn for humanity among the stars, is a prize worth fighting for. This journey is not just about reaching a new world, it's about redefining what it means to be human, about expanding our horizons and embracing the infinite possibilities that lie. Imagine waking up to a sunrise on Venus. As you open your eyes, soft, filtered sunlight streams through the window. You step outside, breathing in the fresh, cool air. Lush vegetation surrounds your home, vibrant and alive. Overhead, a few puffy clouds drift across the sky. This is Venus, transformed. It's hard to believe that this paradise was once a hellish inferno. Venus, our closest planetary neighbor, has long captivated us with its beauty and mystery. But beneath its brilliant facade lies a world of extreme temperatures, crushing pressure, and a toxic atmosphere. Venus is a planet of extremes. It is often referred to as Earth's twin because of its similar size and composition, but the conditions on Venus are anything but Earth-like. Its surface temperature soars above 900 degrees Fahrenheit, hot enough to melt lead. This intense heat is a result of the thick atmosphere that traps solar radiation. The atmospheric pressure on Venus is 90 times that of Earth, which is equivalent to the pressure found 3,000 feet beneath the ocean's surface. This immense pressure would crush any human-made spacecraft that attempted to land without proper protection. The thick atmosphere is composed primarily of carbon dioxide, a potent greenhouse gas. This composition traps heat and creates a runaway greenhouse effect, making the planet's surface unbearably hot. These extreme conditions make Venus the hottest planet in our solar system, even hotter than Mercury, which is closer to the Sun. Despite Mercury's proximity to the Sun, it lacks the thick atmosphere that Venus has, which is why it doesn't retain as much heat. The thick clouds of sulfuric acid that envelop Venus rain down upon the surface. However, the extreme heat evaporates the droplets before they can reach the ground, creating a toxic and corrosive environment. It's a hostile and unforgiving environment, one that has challenged our understanding of planetary evolution. The volcanic landscape and the extreme conditions provide a glimpse into what a runaway greenhouse effect can do to a planet. Over the years, several missions have been sent to Venus to study its harsh environment. These missions have provided valuable data, helping scientists understand not only Venus, but also the potential future of Earth if greenhouse gases continue to accumulate in our atmosphere. Future missions are being planned to further explore this furnace world. These missions aim to uncover more secrets about Venus's past, its present conditions, and what it can teach us about planetary science and climate change. Despite these harsh conditions, Venus holds a special place in the hearts of scientists and dreamers alike. It is often called Earth's twin due to its similar size, mass, and composition. This similarity suggests that Venus may have once been a much more hospitable place, perhaps even harboring life in its distant past. The possibility of a lost paradise on Venus fuels our desire to explore and understand this enigmatic world. And as we learn more about Venus, we begin to wonder, could we ever transform this hostile planet into a second home for humanity? Could we terraform Venus? The idea of terraforming Venus might seem like science fiction, but the possibility is becoming less outlandish as our technology advances. With each passing year, our understanding of space and our ability to manipulate environments grow exponentially. What once seemed like a distant dream is now inching closer to reality. The process would be a monumental undertaking, requiring a multi-pronged approach to address the planet's extreme conditions. Venus, with its scorching surface temperatures and crushing atmospheric pressure, presents a unique set of challenges. However, with a well-coordinated plan, these obstacles can be overcome. The first step would be to cool the planet down. Venus's surface temperature is hot enough to melt lead, so reducing this heat is crucial. This could be achieved through a variety of methods, such as deploying giant solar shades to reflect sunlight back into space. These shades would act like enormous umbrellas, blocking a significant portion of the sun's rays and gradually lowering the planet's temperature. Another method could involve seeding the atmosphere with reflective particles. These particles would scatter sunlight, reducing the amount of heat that reaches the surface. This technique, known as solar radiation management, has been studied for use on Earth and could be adapted for Venus. Once the temperature drops, the atmospheric pressure would also decrease, making the planet more hospitable. Venus's thick atmosphere is composed mainly of carbon dioxide, which contributes to its intense greenhouse effect. By cooling the planet, we can start to thin this dense atmosphere. Next, we would need to introduce water to Venus. Water is essential for life as we know it, and Venus currently has very little. This could be accomplished by redirecting comets or icy asteroids to collide with the planet, delivering vast quantities of water ice. These celestial bodies are rich in water and could provide the necessary resources to create oceans and rivers on Venus. As the ice melts, it would form oceans and create a water cycle, similar to what we have on Earth. This new water cycle would help regulate the planet's temperature and support the development of a stable climate. Finally, we would need to create a breathable atmosphere. An atmosphere rich in oxygen is essential for human survival. This would involve converting the carbon dioxide in the atmosphere into oxygen, perhaps through the introduction of genetically engineered organisms capable of photosynthesis. These organisms could be designed to thrive in Venus's harsh conditions and gradually transform the atmosphere. Over time, the atmosphere would become more oxygen-rich, allowing humans to breathe freely without the need for spacesuits. This transformation would take many years, but the end result would be a planet that could support human life. The dream of terraforming Venus is ambitious, but with continued advancements in technology and a commitment to exploration, it is a dream that could one day become a reality. Section 5, Venus 2090, a progress report. The timeline for terraforming Venus is long, spanning centuries or even millennia. But by 2090, we may see significant progress towards this ambitious goal. Imagine vast solar arrays in orbit, deflecting sunlight and gradually cooling the planet. Robotic probes and landers would be deployed to the surface, collecting data and testing terraforming technologies. The first human missions to the surface of Venus might involve short-term expeditions to establish research outposts and monitor the progress of terraforming. These pioneers would face a challenging environment, but their work would pave the way for future generations to inherit a transformed Venus. Section 6. The ethics of transformation. The idea of terraforming another planet raises ethical questions. Do we have the right to alter another world to suit our needs, especially if it could potentially harbor its own forms of life, even if microscopic? What are the long-term consequences of such an undertaking? These are complex issues with no easy answers. As we venture further into space and develop the capability to alter entire planets, we must proceed with caution and engage in open and honest discussions about the ethical implications of our actions. The decisions we make today will shape the future of humanity and our place in the cosmos, and preserve our own. The lessons we learn from terraforming Venus could be applied to other planets and moons in our solar system and beyond. Imagine the possibilities. Section 8. The future of exploration. The future of space exploration is filled with challenges and opportunities. Terraforming Venus is just one of many ambitious goals that we can strive for as we continue to push the boundaries of human ingenuity. From establishing permanent settlements on the Moon and Mars, to exploring the outer reaches of our solar system, the possibilities are endless. By embracing the spirit of discovery and innovation, we can overcome the challenges that lie ahead and create a brighter future for humanity among the stars. The journey may be long and arduous, but the rewards are immeasurable. Section 9. A universe of possibilities. The universe is vast and full of wonders. As we stand on the cusp of a new era of space exploration, we are limited only by our imagination. The quest to terraform Venus is a testament to the boundless potential of the human spirit and our unwavering desire to explore the unknown. Let us dare to dream big, to reach for the stars, and to create a future where humanity's reach extends far beyond the confines of our home planet. The universe awaits our exploration, and the possibilities are truly endless. Venus, our closest planetary neighbor, has long captivated our imaginations. This enigmatic planet, often referred to as the morning star or evening star, has been a subject of fascination for astronomers and dreamers alike for centuries. Its bright, shining presence in our sky has inspired countless myths, stories, and scientific inquiries. It shines brightly in our night sky, a beacon of celestial beauty. With its radiant glow, Venus is often the third brightest object in the sky, after the sun and the moon. This brilliance is due to its thick, reflective cloud cover, which bounces sunlight back into space, making it visible even to the naked eye. But beneath this alluring facade lies a planet of extreme hostility. The surface of Venus is a harsh, rocky terrain, marked by vast plains, towering volcanoes, and deep canyons. The planet's landscape is shaped by intense geological activity, with evidence of volcanic eruptions and tectonic movements that have sculpted its surface over millions. These clouds are formed by volcanic activity, which releases sulfur dioxide into the atmosphere. The sulfur dioxide then reacts with water vapor to form. Is a stark contrast in terms of its environment and conditions. While Earth is a haven for life, Venus is a hellish world with conditions that are more akin to a vision of the underworld than a sister planet. Yet even in this hellish environment, we dare to dream of a future where Venus is transformed. Scientists and visionaries have proposed ambitious plans to terraform Venus, altering its atmosphere and surface to make it more hospitable to human life. These ideas range from creating floating cities in the upper atmosphere, where conditions are more Earth-like, to engineering massive projects that would cool the planet and reduce its atmospheric pressure. A future where this inhospitable world becomes a second home for humanity. The concept of colonizing Venus is not just a flight of fancy, it represents a bold vision for the future of space exploration and human expansion. By overcoming the challenges posed by Venus's extreme environment, we could unlock new possibilities for living beyond Earth. It's a vision that seems like science fiction, but the seeds of possibility are being sown today. Researchers and engineers are already working on technologies and strategies that could one day make Venus habitable. From advanced materials that can withstand the planet's harsh conditions to innovative methods of altering its atmosphere, the groundwork is being laid for future missions to Venus. The journey will be long and fraught with challenges. Sending humans to Venus and establishing a permanent presence there will require overcoming significant technical, logistical, and financial hurdles. The extreme conditions on Venus mean that any mission will need to be meticulously planned and executed, with contingencies in place for every possible scenario. But the potential rewards are too great to ignore. Successfully colonizing Venus would not only represent a monumental achievement in human history, but also provide valuable insights into planetary science, climate change, and the potential for life on other worlds. The knowledge gained from studying and transforming Venus could have far-reaching implications for our understanding of the universe and our place within it. The transformation of Venus represents not only a chance to expand our presence in the cosmos, but also an opportunity to learn more about ourselves and our own planet. By pushing the boundaries of what is temperatures, it might seem like an unlikely candidate. However, its proximity to Earth and certain similarities make it an intriguing option for terraforming. Gravity is about 90% that of Earth's, which means that humans could potentially walk on its surface without the need for extensive adaptation. Most importantly, Venus possesses the basic ingredients for life as we know it: carbon, oxygen, and water, albeit locked away in its unforgiving environment. The planet's atmosphere is composed mainly of carbon dioxide with clouds of sulfuric acid, but there are trace amounts of water vapor. Unlocking these elements and making them accessible is a key challenge for terraforming. The first steps towards terraforming Venus will focus on stabilizing its atmosphere and cooling its surface. This involves reducing the thick carbon dioxide layer and addressing the extreme greenhouse effect that traps heat. Innovative technologies and methods will be required to achieve these goals. This will be a monumental task, requiring innovative engineering solutions and a global, coordinated effort. International collaboration will be essential, as no single nation has the resources or expertise to tackle such a massive project alone. Space agencies, private companies, and scientific communities will need to work together. Early successes have demonstrated the potential for altering Venus's atmospheric composition. Experiments and simulations have shown that it is possible to change the balance of gases in the atmosphere, paving the way for more ambitious projects. Space-based mirrors, strategically positioned to reflect sunlight away from the planet, could help to lower surface temperatures. These mirrors would act as giant sunshades, reducing the amount of solar energy reaching Venus and gradually cooling it down. Simultaneously, massive carbon capture and sequestration projects could begin to draw out the excess carbon dioxide. By removing this greenhouse gas from the atmosphere, we could start to create a more hospitable environment. These technologies are already being developed and tested on Earth, and adapting them for use on Venus is a logical next step. The vision of a terraformed Venus includes not just a stable atmosphere and cooler temperatures, but also the establishment of human habitats. These habitats would be designed to support life, with controlled environments and sustainable resources. The dream of living on Venus is still far off, but each step brings us closer to making it a reality. Imagine a future where generations of humans can thrive on Venus, enjoying parks, forests, and oceans just like on Earth. The journey to that future is filled with challenges, but the potential rewards are immense. Terraforming Venus is not just about survival, it's about creating a new home for humanity. As we look to the stars and dream of new worlds, Venus stands out as a beacon of possibility. The path to terraforming is long and complex, but with determination, innovation, and collaboration, we can turn this vision into reality. The adventure of transforming Venus awaits, and it promises to be one of humanity's greatest achievements. The thick Venusian atmosphere, a major obstacle to terraforming, also presents an opportunity. Its high carbon dioxide concentration can be harnessed for carbon-based nanomaterials, crucial for building infrastructure on the planet. Furthermore, the sulfuric acid clouds, while dangerous, contain valuable resources. Extracting water and sulfur from these clouds could provide essential building blocks for life and industry. This process of atmospheric engineering will involve a combination of advanced technologies. Orbital mirrors will deflect sunlight, while atmospheric processors, powered by solar energy, will work tirelessly to convert carbon dioxide into breathable oxygen. These processors, resembling giant towers, will become iconic symbols of the terraforming effort. As the atmosphere thins and cools, the extreme surface pressure will gradually decrease. The sulfuric acid rain will cease, and the skies will begin to clear, revealing a transformed landscape. This process will take decades, perhaps even centuries, but the progress made each year will mark a significant step towards a habitable Venus. Even with a more hospitable atmosphere and cooler temperatures, life on Venus will present unique challenges. The planet's surface is still incredibly hostile, with temperatures that can melt lead and an atmosphere filled with sulfuric acid clouds. These conditions make it one of the most challenging environments for sustaining life as we know it. To thrive in this environment, organisms will need to withstand harsh ultraviolet radiation and a still toxic atmosphere. The high levels of UV radiation can damage cellular structures and DNA, making it essential for any life forms to have robust protective mechanisms. Additionally, the atmosphere's composition, primarily carbon dioxide with traces of nitrogen and sulfur dioxide, poses significant challenges for respiration and metabolic processes. Scientists are already exploring the potential of extremophiles organisms that thrive in extreme conditions on Earth to play a role in terraforming Venus. Extremophiles, such as those found in the boiling hot springs of Yellowstone or the acidic waters of Rio Tinto, have evolved unique adaptations that allow them to survive where most life cannot. These adaptations include heat-resistant enzymes, acid-stable proteins, and efficient DNA repair mechanisms. These hardy life forms, found in volcanic vents and deep-sea trenches, possess an incredible resilience that could be harnessed for this new frontier. For instance, thermophiles, which thrive in high-temperature environments, could be engineered to survive Venus's scorching surface. Similarly, acidophiles, which flourish in acidic conditions, might be adapted to withstand the sulfuric acid clouds. Genetic engineering will play a crucial role in adapting these extremophiles to the specific conditions on Venus. By manipulating their genetic makeup, scientists can enhance their natural abilities and introduce new traits that would allow them to survive and even thrive on Venus. This could involve inserting genes that confer resistance to UV radiation or enable the utilization of carbon dioxide for energy production. Scientists envision creating genetically modified algae and bacteria capable of converting carbon dioxide into oxygen, further accelerating the terraforming process. These microorganisms could be designed to perform photosynthesis under Venusian conditions, gradually transforming the atmosphere by reducing carbon dioxide levels and increasing oxygen concentrations. This process, known as bioterraforming, could create a more Earth-like environment over time. These organisms will be the pioneers, paving the way for more complex life to take hold. As the atmosphere becomes more hospitable, more advanced forms of life, such as plants and eventually animals, could be introduced. This gradual progression from simple to complex life forms mirrors the evolutionary history of Earth and could lead to the establishment of a self-sustaining ecosystem on Venus. The development of such life forms is not only crucial for Venus, but also holds valuable lessons for Earth. The techniques and knowledge gained from engineering life for Venus could be applied to address environmental challenges on our own planet. For example, genetically modified organisms could be used to clean up polluted environments, sequester carbon dioxide, or restore damaged ecosystems. Understanding how life adapts to extreme environments could provide insights into combating climate change and preserving biodiversity on our own planet. By studying extremophiles and their adaptations, scientists can develop new strategies for enhancing the resilience of crops, protecting endangered species, and mitigating the impacts of global warming. In this way, the quest to engineer life for a hostile planet like Venus could ultimately benefit life on Earth as well.